Welcome back to Lesson 1. Here we'll look at some more examples involving multiple triangles. So example 1. What is the value of x to the nearest tenth? So if I just look at the triangle on the bottom, the one that involves x, I see that I don't have enough information right now to set up a trig ratio. All I have is an angle, but we need at least one side length. Now this side length here is part of both the triangles, the top one and the bottom one. And if I just look at the top triangle for a minute, I'm able to solve for y by using the Pythagorean theorem, because I'm given two side lengths. The 15 is the hypotenuse, and 9 is one of the legs. So say I got my a squared plus b squared equals c squared, I can find y. So that's step 1. And after we have y, then we'll find x. So now 9 squared is 81, and 15 squared is 225. Now I'm going to subtract 81 from both sides. So I get y squared equals 144. Now we need to find the square root of 144, which is 12. So now this side length is 12. So now looking at my 24 degrees, I see that 12 is opposite and x is the hypotenuse. That means sine can now be used to find x. Setting up the sine ratio, I get sine of 24 degrees equals opposite over hypotenuse. Cross multiplying, x times sine 24 equals 12. Now I have to divide. So working this on my calculator, I get that x equals 29.5. Now for example 2. What is the length of side BC to the nearest tenth? So if I look at this triangle on the right, the one that includes side length BC, again I see that I'm not given enough information right now in order to find BC. All I have is an angle. So the general approach with these is to find the side that the two triangles have in common. So for example, this side here. So I'm going to use the triangle on the left, the one with the 57 degrees, to help me find x. Then after I got x, I can then find BC. So in order to find x, I'm going to use the tangent ratio. So tan of 57 degrees equals x over 7.2. Cross multiplying, I get 7.2 times tan 57, which gives me 11.1 on the calculator. So now that I know that x is 11.1, I'll call this one here y, I can use opposite and hypotenuse. I can use sine now to find y. Sine of 28 equals, opposite is 11.1 over y. Cross multiplying, and then dividing will give me my answer. Putting that in the calculator, I get that y is equal to 23.6. So that means BC equals 23.6. And now for this last example, we're looking for an angle here. What is the value of theta to the nearest degree? So looking at the triangle on the right, again the one that involves the theta, I see that I don't have enough information. I only have one side length. I need to find this side length here, because this side is in common with the triangle on the left. So now setting up adjacent and hypotenuse, setting up the cosine ratio will help me find x. So cosine of 53 equals x over 54. So x is going to be whatever 54 times cos 53 is. And working that out, I get a value of 32.5. So now looking at theta, the x is the opposite side and 22 is the adjacent. So now I'll use tan to find theta. Tan theta equals the opposite side, which is 32.5, over the adjacent side, which is 22. And when we look for an angle, we have to use our tan -1 button. And putting that in my calculator and rounding it to the nearest degree, I get 56 degrees.